Good morning, welcome to
Family Math number 99.
Family Math number 99. This morning, I was reading a really cool article by the physicist Frank Wilczek, who won the Nobel Prize in Physics in 2004.
Yep.
It's an awesome article. It's called Triumph, Window, Clue, and Inspiration. And you can find it on the internet, actually. So if you search for this article, you'll see it. It's an awesome article about the Higgs Boson.
Yep.
And the guy who predicted the Higgs boson, do you know what his name is?
No.
Mr. Higgs.
Mr. Higgs.
Mr. Higgs found won the Nobel Prize in Physics just this past week. And so in this article, we learned that the lifetime of a Higgs boson is 10 to the minus 22 seconds. Do you know what 10 to the minus 22 means?
It's 1 over, was it?
It's 1 divided by 10 to the 22nd. Remember, we're studying that.
Oh, yeah.
Yeah, and then I wrote out what 10 to the 22nd was. You see how big of a number that is?
Yeah, it's a 1 with 22 zeros.
That's 1 with 22 zeros. Yeah, and that's why this notation with powers saves us a lot of time. Otherwise, we'd have to write out.
I think
all
it's
these
10 septillion.
Sextillion, I think. Let's see. 1,000, million, billion, trillion, quadrillion, quintillion, sextillion.
And then there's this little, you forgot to count them.
But no, this is with 1,000. If there was a 1 there, that'd be 1,000.
Oh, yeah.
1,000, 1 million,
Billion.
billion, trillion, quadrillion, quintillion, sextillion, 10 sextillion. Whoa.
That's
10
a
over 10
lot.
sextillion.
Yeah, but it's the number's so big, or the reciprocal 10 to the minus 22 when we put it on the bottom.
Yeah.
It's so small, it's hard to understand,
Yes.
right? Like we don't encounter that number very often. That's how long the Higgs boson lives, 10 to the minus 22 seconds.
It's
Like how long have you lived, for example?
10 years.
Yeah, that's longer than that, right? So I'm gonna try to explain like one way of thinking about it, but I don't think there's any real good way to think about it. It's very difficult to understand. So the diameter of a hydrogen atom is about 10 to the minus 10 meters. That's called 1 angstrom. So that's super tiny. That's how big a hydrogen atom is. Do you see any hydrogen atoms anywhere?
No, we can't
No.
see them.
Yeah, they're so small you can't even see them. And the radius of Pluto's orbit, now this isn't quite right because Pluto's orbit's really elliptical, right? But it's about, I had to go really far out, so I had to go so far out to Pluto. The radius of Pluto's orbit, if you pretended it was a circle, is about 5 times 10 to the 12th meters.
Yeah.
Okay? So if you started at the sun, okay?
Yep.
So this is you.
Yep.
And you went to the sun. It's not a very good picture of you, is it?
No.
No, it's okay. But here you went to the sun. Yay! You think you'd be warm or hot?
Hot.
It's really hot.
Flaming hot.
And then here's Pluto out here. And you started laying down hydrogen atoms right next to each other and walked all the way from the sun to Pluto, ... and put down one hydrogen atom right next to another one, right next to another one, right next to another one, right next to another one. By the time you got to Pluto, you would have put 5 times 10 to the 22nd hydrogen atoms down.
Whoa.
Well, so if you can imagine laying down hydrogen atoms right next to each other, starting at the sun, going all the way out to Pluto, that's sort of how big 10 to the 22nd is.
Whoa.
That's how many hydrogen atoms you would need. Do you have that many hydrogen atoms?
Well, we have a lot of them.
No, we do. Maybe we have enough. Should we try this?
We can't actually place them down side by side.
That's true. That would be kind of hard.
Yeah.
Well, but that's okay. So, but you can imagine it, right?
Yeah.
This line of hydrogen atoms.
Yeah.
Okay, now, if you took, even though there's 5 times 10 to the 22nd of these,
Yep.
so that means if you took 5 of those atoms out, that would be the equivalent of 10 to the minus 22nd.
Ooh.
Ooh, so the distance from the sun to Pluto compared to 5 hydrogen atoms, that's what 10 to the minus 22nd is. So that does not live very long,
Yeah.
right? Think it's that long?
Probably even less.
That long? Way less. Way less.
You're probably not even finished being born, then you die.
Yeah, exactly right.
Actually, maybe it's if they're so slow. How can they find a mate but they'll probably die sooner if they can.
Yeah, well, that's what the physics people study. Yeah. That's a really neat thing about this. They come into existence and then they vanish. Pretty cool. All right. Good job, guys. Good job.